Hi friends, in my previous video, I already explained about the production of magnetic field using a straight wire where the current is passing through it. Now we will see one more topic where the magnetic field is produced due to a solenoid. So this is our activity name. Let's proceed by using the solenoid how the magnetic field is generated. We will see in this total activity. So without wasting the time, let's proceed to our activity. So take a wooden plank covered with a white paper, make equidistant holes on its surface as shown in the figure 6a. So for this activity we required a wooden plank, and on this wooden plank we are placing a white sheet, and on the white sheet we are making the equal distance holes. Next, pass a copper wire through the holes as shown in the figure 6a. So as shown in the figure, we have to pass the copper wire through the holes. Next, this forms a coil. So after passing the wire into the holes, we can observe that the wire, it will be in the form of a coil. Next, join the ends of the coil to the battery. So here we can see that the coil which is formed, it is passing through a battery through a switch. This is the total activity, the apparatus, the circuit which is formed. A coil which is passing through a holes. Next, it is connected to a switch. Later it is connected to a battery. Next, switch on the circuit. So what happens after connecting it to the battery? We have to switch on the circuit. If you on the circuit, what happens? The current will pass from the battery to the coil. The current passes through the coil. Now sprinkle the iron fillings on the surface of the plank around the coil. So as you have formed a coil, around the coil we have to sprinkle some iron fillings on a wooden plank. Next, give a small jerk to it. An orderly pattern of iron fillings is seen on the paper. So after dropping the iron fillings around the coil, if you jerk, we have to jerk means we have to make the sudden disturbance to the wooden plank. What happens? The iron fillings will be forming one pattern around the coil. Next, how do they adjust in such an ordinary pattern? So here one more question is asking. See, it is asking that why the iron fillings are chosen only that pattern. So this is the case we have to get the doubt. So let's proceed to solve the doubt. This long coil is called as a solenoid. So whatever the coil we have made, this is called as a solenoid. So this is the topics, the magnetic field due to solenoid. So we got the long coil, it is called as a solenoid. A solenoid is a long wire wound in a closed packed helix. So this is the case. A solenoid is a long wire which is packed in a helix. What will say? It is packed in a helix. The field of the solenoid is shown in the figure 6b. So in this case, the solenoid is shown. See, all the wire, long wire, which is curled one, it is called as the solenoid. The magnetic field lines set up by a solenoid resembles those of a bar magnet, indicating that a solenoid behaves like a bar magnet. So whatever the magnetic field it is created by the solenoid, it is same like the magnetic field which is generated by the bar magnet. So we know bar magnet, it produces the magnetic field which is passing from north to south. Next, inside this we cannot see, but the magnetic field will be passing from south to north. It is a closed magnetic field we can observe in bar magnet. So same as like bar magnet only, the solenoid will also produce the magnetic field. Next, the direction of the field due to the solenoid is determined by using the right hand rule. So in previous video I already explained the right hand rule. So I will give the link of the video in the description, try to check. So the right hand rule, it says that the thumb finger, if you catch any conductor carrying which is current, so if you catch the wire, the thumb finger, it will show the current direction, and the curled fingers, it will show the magnetic field. So this is the right hand rule. Try to check this in the video which will give the link in the description. One end of the solenoid behaves like a north pole and other behaves like a south pole. So in this case, for the solenoid, one end will behave like a north and the opposite will behave like a south. The field lines outside the solenoid are continuous with those inside. So the field lines which are passing from the outside, it will be continued from the inside. This is the total continuous process of the field lines. Next, outside the solenoid, the direction of the field lines is from north to south, while the inside the direction is from south to north. So this is the case in how the magnetic field is moving. So from the outside we can see that the outside fields are moving from north to south and inside fields are moving from south to north. This is a total continuous process. It may be at any other side. See, the outside it will transfer from north to south and inside it will transfer from south to north. This is the total. Next, as the magnetic field lines are closed loops, this is so far that the bar magnet too. So this is the case. So is comparing the solenoid with the bar magnet. Since we can observe clearly that the magnetic field which is produced by the solenoid is similar to the bar magnet. This is the case total. Next, we have seen that current carrying wires produce magnetic field. So electric charges in motion produce magnetic field. So from the previous activity and from this activity we can conclude that if a current is passing through a coil, it produces the magnetic field, and by this we can conclude that see the motion of the electric charges in motion produces the magnetic fields. This is the important point. So from these two videos we can conclude that if a current is passing through a wire, it produces magnetic field around the wire. So previous it was a straight wire, so we can see the magnetic field around the wire. Here the wire is in it is in curled shape and it is forming one helix. In this case we can see the field is in like bar magnet structure. So I hope you have understood the two cases where the magnetic field is generated by using the passing of current through a wire.